All right, then, econ friends, welcome back to another lecture. Up until this point, what we have done is built up a pretty comprehensive view of the supply and demand model. So we know, number one, that the supply and demand model represents a competitive market. We know that the supply curve is representative of the incentives, decisions, trade-offs, motivations of countless sellers, and the demand curve represents the incentives and motivations and the pursuit of utility of countless buyers. We put those together in our supply-demand model at equilibrium, and we've discussed the equilibrium adjustment process. We've discussed shifts in curves. At the end of it, though, we know that the equilibrium process gets us to equilibrium price, and prices play key features in economic market theory. We then added to it a bit of nuance with our discussion of elasticity. So at this point, maybe you're saying, okay, I understand the competitive supply-demand model, I understand the shifts, I understand how to predict price changes, but so what? So let's put this now in the context. Let's take our supply and demand model, our idea of a market model, and let's put it in the context of the bigger economic question, and that is the question of efficiency. So in this module, we're going to be discussing the supply-demand model, but in the context of something bigger, and that is the idea of efficiency and the invisible hand. And what we're going to see in this is that when they function well, especially when they're grounded in a competitive model and with strong property rights, competitive markets have the power to be very efficient. And that's an important thing for society. Let's jump into it first with a quick overview of economic efficiency. And we can define economic efficiency quite simply as any situation in which all the potential gains from trade have been realized. Again, economic efficiency basically can be seen as any time you have a situation in which all of the potential gains, all the potential win-wins from trade have been realized. Now, earlier, we discussed the idea of productive efficiency, which we defined as obtaining the maximum possible output with a given set of resources, or seen differently, obtaining output for the lowest possible cost, okay? And that's productive efficiency, which is one metric of overall economic efficiency. But for the purposes of this discussion, we're going to turn our attention to what we're going to call allocative efficiency. Allocative efficiency is defined as obtaining the maximum well-being from producing what we'll call the right set of goods and services. So again, you can think of productive efficiency as, are we producing whatever we decide to produce at the lowest cost? Allocative efficiency is asking, but are we producing the right mix of things in order to satisfy people's overall wants? In general, some rules with efficiency. In general, undertaking any economic action is efficient if it produces more benefits than costs. Again, undertaking any economic action is efficient if doing that action leads to more benefits than costs. On the other hand, undertaking an economic activity is inefficient if it produces more cost than benefit. So if any activity is going to generate more cost than gain, we would call that inefficient. And then broadly speaking, by definition, in economic theory, either a failure to undertake an efficient action, in other words, not carrying out what is an efficient action, or undertaking an inefficient action, so again, either having an opportunity for an efficient action and not taking it, or undertaking an action that is defined as inefficient, both of those will result in the broad condition of economic inefficiency. We can actually show that in a real simple graph. If we take our old marginal cost and marginal benefit graph, we've learned that over time, the marginal benefits of an action fall, while over time, the marginal cost of an action increase. And the point right here, where the marginal costs equal the marginal benefits, if you drop a line down, this we would call the optimal output level. Because if you notice at this point, again, where the marginal cost equals the marginal benefit, you have taken each and every trade for which marginal benefit exceeds marginal cost, but you have not crossed over into the area where marginal cost exceeds marginal benefit. So a really important rule to keep in mind in economic thinking is the optimal amount of any activity occurs at the point where the marginal costs and the marginal benefits are equal. Now, if you wanted to adopt this to what we just did in our last couple of lessons, you may see some similarities. We take our equilibrium supply-demand model, and in fact, we believe in economics that the supply curve represents the marginal cost of production for the sellers, and the demand curve represents the marginal benefit for buyers. So the supply and demand curves can be seen as a way to express the marginal cost and marginal benefits in a market. And just like we said a moment ago, that the optimal quantity is where marginal cost and benefit equal, now you see why equilibrium in our competitive model, where supply and demand equal at equilibrium, and that gives us our equilibrium output and our equilibrium price, why that's such a critical place. Because we're going to argue in a minute that a competitive market at equilibrium is an efficient market. Okay? With that said, let's jump into it. In order to understand economic efficiency and the idea of competitive markets, we're going to turn back to something that we touched on before, and that's a discussion of consumer surplus and producer surplus. We introduced those briefly in our discussions on the supply and demand curves. Now we're going to put them to use. Broadly speaking, when markets are competitive and when property rights are enforced, we believe that the market equilibrium, in other words, that point where supply equals demand, again, when a market is competitive and when property rights are enforced, we believe that the market equilibrium will satisfy economic efficiency. And the reason for this is we believe that at equilibrium, we're going to maximize total surplus. Again, we believe that in a competitive market at equilibrium, at the equilibrium price, we are going to maximize total surplus. Total surplus is a new concept, but you already know the basics behind it, because total surplus is simply the sum of consumer surplus and producer surplus. In other words, we learned that consumer surplus represented the gains to buyers when they exchange and trade, and we learned that producer surplus was the gains to sellers. Total surplus, therefore, consumer surplus plus producer surplus equals total surplus. You can see total surplus as the overall gains to all of society, to all the buyers and all the sellers when we have market exchange. Okay, so again, total surplus, a really important idea. It's the sum of the consumer and producer surpluses, and it is basically a measure of the total gains that society as a whole, all the buyers and all the sellers, society as a whole gets from market exchange. Since total surplus is a critical concept in gains from trade, we believe in economic theory that we always want to maximize total surplus. Seen a different way, any policy or any activity that increases total surplus would probably be judged to be economically good. And at the same time, any activity that were to somehow reduce or decrease total surplus would need to be looked at very critically, because that implies that it's reducing the net gains to our society. Okay, really quickly, I'm showing you here something that you already had. Let's just get a quick look at it. We know that consumer surplus was defined as the gap between how much a producer is willing to pay and what they actually pay. And therefore, it could be seen as the triangle below the demand curve and above the price. And this triangle below the demand curve and above price was consumer surplus. We also know that producer surplus was the difference between how much a seller actually sold a product for and what they were willing to sell it for. And therefore, we can graphically see producer surplus as the area below price and above the supply curve. So again, another triangle. And this triangle here would be producer surplus. And therefore, if you know that total surplus equals consumer plus producer, we can identify total surplus as this big triangle right here that adds up consumer and producer. The critical thing to bear in mind is, notice we have a market here. We have a supply curve sloping down, upward. We have a demand curve sloping downward. We have right here, as you know, our equilibrium point. Notice that at market equilibrium and at this equilibrium quantity and this equilibrium price, by definition, total surplus is maximized, because you cannot get that triangle any bigger, ceteris paribus. Okay? So again, we're building into a discussion, we're building into a model where we're going to argue that a competitive market with supply at equilibrium is going to generate an output, equilibrium quantity, and a price, equilibrium price, that maximizes the size of our total surplus triangle. Okay? To understand that, it's helpful to take a look at a situation when markets are not in equilibrium. And in fact, when a market is not in equilibrium, we may have a situation in which what we call a dead weight loss occurs. Call that DWL. So again, we saw up here that when a market is in competitive equilibrium, total surplus is maximized. We're going to argue that if markets are not in equilibrium, we may have a situation called a dead weight loss. And a dead weight loss is defined as the reduction in total surplus that results from a market distortion. In other words, dead weight loss is the reduction in total surplus that society has to endure. It's the reduction in net gains from trade that society has to take on whenever a market is distorted or otherwise is unable to reach equilibrium. You see right here, we took another supply and demand curve. So we have our supply and we have our demand. Notice that if this market were to hit equilibrium, it would occur here. So this would be the equilibrium point. Again, where supply equals demand. And we know that at this equilibrium point, we would get this particular quantity and we would get this particular equilibrium price. And touching on what we just went over, if this market were indeed to be at equilibrium, producing 3 units at an equilibrium price, we would have a total surplus the size of this really big triangle. Total surplus would be maximized, and society would be made better off because we would get as many possible gains from trade as possible. We would achieve economic inefficiency. We just went over that. We did it again here. But now let's suppose that something happened, and instead of 3 units at equilibrium, we somehow had 2 units. We'll discuss how that can happen later, but for now, just suppose that while market equilibrium should be 3 units, instead, we're somehow only getting 2 units. In other words, we're not achieving the full equilibrium output. We'll discuss why in a minute. Well, if this happens, notice that if you take this up, this is the quantity of 2. And if you notice here, going back to our definitions, consumer surplus is going to be a smaller triangle than before. Actually, not a triangle anymore. And producer surplus would also be reduced. In other words, the original big triangle that we had, this full size one, this big triangle that maximized total surplus is going to be reduced. The amount by which it's reduced is this triangle here. And that triangle, again, the reduction in total surplus, the piece of the triangle that's being chipped away, that is known as deadweight loss. Notice that deadweight loss is the triangle, and it is bordered by the supply curve on the bottom, by the demand curve on the top, and that the base of it is the difference between how much was produced at equilibrium and this artificial amount. So it's a triangle, again, bordered by the supply and demand curves, and on the left by the inefficient, artificially low output level. Either way, it's really important to understand that because we're not at equilibrium here, because we're producing 2 units and not 3 units, society suffers. Total surplus is reduced. In other words, the gains from trade, the potential win-win-win-win transactions that would make buyers and sellers happier, those are reduced. We should be having 3 of them, but we're not. We're only getting 2. And because trade is artificially low, some potential win-wins are not going to happen. That's a destruction of total surplus, a loss in consumer value. And that's measured, my friends, by this triangle, deadweight loss. Okay. The idea of deadweight loss, to conclude this, is really important because, number one, our goal is to maximize efficiency and to maximize total surplus. Oftentimes, however, government and other entities seek to bypass market mechanisms. And therefore, the deadweight loss concept is extremely important and is used by economists in many ways, but primarily to evaluate whether any government policies, in other words, any government interventions in the market system, are those interventions beneficial or are they harmful? And we'll discuss this more in detail in our next video. Thanks, and I'll see you in a bit.